Hello, and welcome to Quiet Learning for Sleep. This is your peaceful space to unwind, to let go of the day, and to drift into deep, restful sleep while learning softly about our universe. Here, we take gentle journeys through calm ideas, stories from science and nature, space and time, history and life, all whispered at a soft pace, without rush, without noise, and without pressure. You do not need to focus or remember anything. This is learning the quiet way, where your mind floats and drifts and rests, while curiosity stays softly awake in the background. If you'd like, before you get comfortable, you can subscribe and gently like this video. Doing it now means you won't forget later, and it helps others like you find this calm, sleepy corner of the world. Now, allow your breath to slow just a little. Let your shoulders relax. Let your thoughts soften, like clouds drifting across a calm evening sky. There is nowhere you need to go, nothing you need to do, and nothing expected from you here. This time belongs to rest, comfort, and gentle curiosity. And if you drift to sleep along the way, that is not only allowed, it is welcome. So settle in, let yourself melt into stillness, and allow your mind to float quietly as we begin. The Silent Companions. Introduction to the moons of the solar system. In the stillness of space, planets drift like lanterns in the dark. Around many of them, smaller worlds follow, faithful companions bound by invisible threads of gravity. These are the moons of the solar system, the silent witnesses to creation. They have no light of their own, yet they shine with borrowed brilliance, reflecting the story of the worlds they orbit. From afar, moons may seem alike, gray, cratered spheres circling their planets, but each is as unique as a fingerprint. Some are oceans of molten fire, others frozen deserts of ice. Some whisper with geysers that pierce the void, others echo with the scars of ancient collisions. To know the moons is to read the diary of the solar system itself, written in the language of stone and silence. Human eyes first met a moon, long before telescopes. Our ancestors watched the pale face of Luna wax and wane across the night sky, its rhythm marking time and tide. To them, it was more than rock. It was a god, a guardian, a companion in the dark. Every civilization carved its name into myth. Selene and Artemis in Greece, Chandra in India, Tsukuyomi in Japan. The moon became a mirror for the human spirit, a reminder that light can endure even in darkness. When Galileo turned his telescope toward Jupiter in 1610, he found something that changed humanity's place in the cosmos. 4 small stars seemed to move with the giant planet. They were not stars at all, but moons: Io, Europa, Ganymede, and Callisto, worlds circling another world. For the first time, we saw that Earth was not unique. The heavens were not perfect crystal spheres. They were a living, changing system, filled with countless centers of motion. As centuries passed, more moons revealed themselves. Telescopes grew stronger, and the shadows of Saturn and Uranus gave up their secrets. By the time the space age began, we had discovered dozens. Now we know of hundreds. They orbit every planet except Mercury and Venus, whose proximity to the sun stripped them bare. Even some asteroids and dwarf planets, like Pluto, keep their own satellites. Proof that companionship is one of the universe's favorite designs. But what exactly is a moon? In the simplest sense, it is any natural body that orbits another, larger one that is not the sun. Yet the simplicity of that definition hides extraordinary variety. Some moons formed alongside their planets, coalescing from the same disk of gas and dust. Others were captured later, pulled in from wandering orbits by a giant's gravity. A few were born in violence, torn from their parent worlds by cataclysmic impacts. Each carries a different origin story, etched into its composition and motion. Our own moon is a child of disaster. Long ago, a planet-sized body struck the young Earth, scattering molten rock into orbit. Those fragments gathered, cooled, and became the companion that now governs our tides and illuminates our nights. Without that impact, life on Earth might never have stabilized. The moon's steady pull has kept our planet's tilt and seasons in delicate balance for billions of years. The moons of Jupiter tell another story, a family shaped by gravity's tug of war. Io blazes with volcanoes so powerful they can be seen from space, while Europa hides a vast ocean beneath its icy crust. Ganymede carries its own magnetic field, the only moon to do so, and Callisto's surface preserves craters from the dawn of time. Together, they are a miniature solar system, orbiting within Jupiter's magnetic embrace. Saturn, the ringed giant, hosts an even richer court. Titan, with its golden haze and rivers of liquid methane, mirrors the processes that once sculpted Earth. Enceladus, gleaming white, vents fountains of ice into space, hinting at another hidden ocean beneath. Beyond them lie small, irregular moons, some shepherding Saturn's rings, others tumbling like captured asteroids. Each plays a role in maintaining the planet's fragile balance of dust and gravity. Farther out still, Neptune's great moon Triton moves against the flow, orbiting backward, a captured wanderer from the Kuiper Belt. Its surface, frozen nitrogen and pink frost, betrays the faint warmth of internal activity. Pluto and Charon, on the frontier of our solar system, circle each other like twins, locked in a slow cosmic dance that blurs the line between planet and moon. And yet, these are only the moons we can name. Beyond them lie countless fragments, tiny satellites orbiting asteroids, ring particles behaving like miniature moons, and perhaps even hidden companions of dwarf planets, still waiting to be found. The solar system is not a collection of lonely worlds. It is a web of relationships, bound by motion, time, and light. Throughout human history, moons have shaped our imagination as much as our science. The moon inspired calendars and poetry, guided sailors across the oceans, and drew philosophers to ponder eternity. In myths, moons were lovers and tricksters, symbols of renewal and madness. In science, they became laboratories of nature, testing grounds for the laws of gravity and the possibilities of life. When astronauts first stepped onto the lunar surface in 1969, they carried not just human footsteps, but the echo of every story ever told about that glowing orb. Their journey was the fulfillment of an ancient curiosity, the urge to reach the unreachable companion that had followed us through all of history. Now, as our probes and telescopes extend our reach, we are discovering that nearly every planet has moons of its own, some larger than Mercury, others smaller than mountains. Each one adds a verse to the grand symphony of the solar system. The diversity of these worlds suggests that moons may be common throughout the universe. Wherever planets form, moons may follow, offering shelter, stability, or even oceans where life could awaken. In this series, we will journey across these worlds. We'll begin close to home, with Luna, our eternal mirror, then venture outward to the volcanic fury of Io and the icy promise of Europa. We'll glide across the vast surface of Ganymede and listen to the ancient silence of Callisto. We'll drift through the golden haze of Titan, skim the icy plumes of Enceladus, and travel to the distant realms of Triton and Charon. Each moon will offer a new lesson, a new reflection on what it means to orbit, to endure, to shine with borrowed light. But we will also acknowledge the many others, the countless small companions whose stories remain half-told. There are moons around Mars, like Phobos and Deimos, racing through its dusty sky. There are irregular satellites of Jupiter and Saturn, their orbits stretched and tilted by past encounters. There are hidden worlds, still waiting in the shadows beyond Neptune, frozen and faint, keeping their secrets for now. Each moon, no matter how small, is part of a larger pattern, the universe's tendency to gather, to orbit, to stay together through invisible connection. Just as our own lives circle around relationships and gravity of the heart, so too do these worlds trace paths of belonging. In their silence, they reflect our own search for companionship and meaning amid the vastness. So as you listen tonight, let yourself drift outward from Earth. Picture the sun as a golden hearth at the center, and around it, the planets turning like slow dancers. Around those planets, dozens upon dozens of moons glide through the darkness, each one illuminated by a faint echo of sunlight. The solar system becomes a family, vast, ancient, and endlessly patient. This is the beginning of our quiet voyage, a journey through the moons of the solar system. Over the coming nights, we will learn their stories, not in haste, but with wonder. You will hear of worlds of fire and ice, of places where water hides beneath frozen crusts, and of others where mountains glow in sulphurous light. We will listen to gravity's song, to the rhythm of orbits, and to the faint, eternal hum of creation itself. The moons wait for us, unchanging, enduring, silent companions of their planets. They do not rush. They do not fade. They keep turning faithfully around the worlds that gave them purpose. And tonight, as you close your eyes, you may feel yourself turning too. Slowly, gently, in harmony with all that circles in the dark. From the moment humanity first looked up, one light has followed us faithfully across the ages. The moon, Luna, Earth's eternal mirror, our closest neighbor and oldest companion. She rises and falls with unchanging grace, pulling at our oceans and our imaginations alike. To watch the moon is to watch time itself unfolding in quiet rhythm, a reminder that even in darkness, there is light that never leaves us. Luna was born from fire and ruin. Over 4 billion years ago, when the Earth was still molten and chaotic, a wandering world, roughly the size of Mars, collided with it in a cataclysm so violent it melted stone and tore mountains from the crust. From that cosmic wreckage, molten fragments coalesced into a single glowing sphere. As the Earth cooled and the debris settled, that sphere began to orbit, first close, then slowly drifting outward. Thus began a dance that has lasted ever since. The planet and its moon locked together, turning in silent harmony. In those early days, Luna loomed enormous in the sky, 3 times closer than today, lighting the young Earth with a silvery brilliance. Her gravity stirred the newborn seas, creating tides that sloshed against volcanic shores. Those tides became the world's first rhythms, the cosmic heartbeat that may have helped shape the chemistry of life itself. Molecules mixed, broke apart, and joined again in the shallow pools left by retreating waters, each tide a new experiment in the long alchemy that would one day lead to us. Even now, the moon continues to sculpt our world. She draws the oceans toward her, creating tides that regulate climate and nurture ecosystems. She stabilizes Earth's axial tilt, keeping our seasons in balance. Without her, our planet would wobble like a spinning top, veering between extremes of heat and ice. The quiet moonlight that glimmers on water each night is not just beautiful, it is the echo of a gravitational bond that sustains life. For early humans, Luna was more than a celestial body. She was a presence, a constant companion who changed yet remained. Hunters followed her light across savannas. Gatherers measured her phases to track time and harvests. Her waxing and waning became our first calendar, her glow our first lantern. Before we built clocks, before we wrote words, we lived by her rhythm. The moon's cycle of birth, fullness, and renewal gave structure to human life long before civilization began. Every culture found its reflection in the moon. To the ancient Greeks, she was Selene, riding her chariot across the night. The Romans called her Luna, serene and eternal. The Egyptians saw her as Thoth, the god of wisdom and measure. In China, she became Chang'e, who drank the elixir of immortality and floated to the heavens. In countless myths, she was mother, lover, guardian, or trickster, always luminous, always distant. Across continents, people wove her into their faiths, believing she governed fertility, dreams, and madness alike. Even her blemishes, those dark basalt plains we call Maria, became symbols, rabbits, faces, and gods etched in eternal stone. As civilizations rose, Luna's importance deepened. The Babylonians aligned temples to her light. The Mayans charted her cycles with mathematical precision. Poets and prophets invoked her to speak of love and longing. Her phases inspired rituals and prayers, planting seasons and sacred festivals. The moon taught humanity constancy. Her return each month proof that order could exist in a chaotic world. Under her light, the boundary between heaven and earth always seemed a little thinner. Then came the age of reason. When Galileo lifted his telescope, he discovered that Luna was not a perfect divine orb, but a rugged physical world. Mountains, valleys, and shadows stretching hundreds of miles. That revelation was both humbling and thrilling. The moon was no longer a symbol alone, it was a place. Later, astronomers mapped her craters and named them for scientists, philosophers, and explorers, as if acknowledging that she belonged to all who dared to wonder. In the 20th century, our fascination became footsteps. Rockets thundered into the sky, carrying human dreams across the void. When Apollo 11 touched down on the Sea of Tranquility in 1969, humanity met its ancient companion face to face. For a moment, the divide between myth and science disappeared. The moon that poets once worshipped became the same moon beneath our boots, its dust glimmering under an alien sun. Yet even then, she remained unchanged, cold, silent, unyielding, watching as she always had. Standing on that gray plain, the astronauts looked back at Earth and saw a fragile blue marble suspended in blackness. It was Luna who gave us that view, our first true glimpse of home as a single, living world. Her reflective surface turned the gaze of humanity inward. The moon became a mirror, not only of sunlight, but of self-awareness. Through her, we began to understand our place in the cosmos. Small, delicate, yet luminous in our own way. Though she is barren and airless, the moon continues to touch every part of human life. Artists still paint her, lovers still walk beneath her, and scientists still plan their return. Future explorers dream of lunar bases carved into shadowed craters, where sunlight can be harvested and water mined from ice. In that sense, Luna may one day become humanity's second home, the bridge between Earth and the greater universe. Modern missions continue her exploration. Probes from many nations have traced her surface, mapped her minerals, and confirmed ice hiding in her polar shadows. China's Chang'e missions have brought samples from her far side. India's Chandrayaan discovered traces of water. NASA's Artemis program now plans to return astronauts to her soil, not just to visit, but to stay. Luna, once unreachable, is becoming familiar again, a laboratory for science and a launching point for the stars. Yet even as our understanding grows, her mystery remains. No telescope or rover can capture the emotion of moonlight spilling across a quiet landscape, or the feeling of standing beneath her rise on a still night. She stirs something ancient within us, a recognition that while we have learned much, the universe remains vast and humbling. In her calm silence, we sense the echoes of creation itself. The moon's influence extends beyond science into the patterns of our cultures. Many calendars still follow her phases. The Islamic months begin with her crescent, and festivals from Easter to Diwali are set by her light. Her cycle of growth and renewal mirrors the rhythms of the human spirit: beginnings, endings, and returns. Writers from Shakespeare to Basho have drawn upon her as muse, and her glow has illuminated more poetry, music, and prayer than any other object in the sky. Luna's pull is emotional as much as physical. Her light softens the world, revealing it in shades instead of absolutes. She is the symbol of reflection, of quiet thought, of dreams that thrive in darkness. For millennia, her phases have mirrored the cycles of human life: birth, growth, decay, and renewal. She reminds us that change is natural, that even after darkness, light returns. To sleep beneath her is to rest in the rhythm of the cosmos itself. Her surface bears scars of a violent past, yet she endures, whole, steady, resilient. In that, Luna becomes a symbol of persistence. She teaches patience and renewal, that even after the heaviest impact, there is still light to give. To many ancient peoples, she embodied the divine feminine, steady, yet ever-changing, luminous yet distant. In a world that often celebrates the sun's brilliance, the moon reminds us of the power of quiet strength. And so, every era finds its reflection in her. The same moon that guided the first farmers now glows over modern cities, washing skyscrapers and deserts alike in silver calm. The same light that stirred ancient myths now illuminates satellites orbiting her. Through all our progress and turmoil, Luna remains the silent constant, a beacon of continuity between past and future, dream and discovery. In time, we will return to her. Humans will once again walk on her plains, perhaps build shelters within her craters, and gaze back at Earth as the astronauts once did. From her soil, rockets may one day leap farther still, to Mars, to asteroids, to the outer worlds whose moons await their turn to tell their stories. Luna will be the threshold, the luminous bridge between the human world and the cosmic beyond. Yet, as we prepare to leave her again, we know we can never truly part. The moon is woven into our biology, our culture, and our imagination. She lives in our tides and our stories, in our calendars and our songs. Every child who looks up at night meets the same familiar light that shone upon the first human eyes. She is the link between what we were and what we may become. In the chapters that follow, we will leave her glow behind and journey outward into the deeper night where other moons circle distant giants. The next world we visit will be a realm of fire and fury, a place of endless eruption where the ground itself is alive. Its name is Io, Jupiter's volcanic moon, a world that burns with restless energy. But before we travel there, take a moment to imagine Luna once more, glowing softly above the sleeping Earth, ancient and patient, watching us with quiet love as she always has. Far from the gentle light of our moon lies a world of fire and motion, a restless moon orbiting the giant planet Jupiter. Its name is Io, the most volcanic place in the entire solar system. Where Luna glows with reflection and stillness, Io burns with energy and violence. To look upon it is to witness a world forever in the act of becoming, reshaping itself every moment beneath a tide of molten rock. Io was discovered in 1610 by Galileo Galilei, alongside 3 of Jupiter's other great moons, Europa, Ganymede, and Callisto. To Galileo, these 4 tiny lights moving around the enormous planet were proof that not everything revolved around Earth. That discovery changed the course of science forever, yet even he could not have imagined the world that Io truly is. A sphere of fury wrapped in sulfur and flame, locked in an eternal struggle with Jupiter's immense gravity. Io is roughly the size of our moon, but the resemblance ends there. Its surface is painted in yellow, orange, and red, streaked with dark scars where volcanoes have torn the crust apart. From orbit, it looks like a living ember, a planet-sized wound that never heals. Beneath that vivid skin lies a restless heart, a mantle of molten rock that churns under relentless stress. Io orbits closer to Jupiter than any of the other large moons, and the planet's immense gravity stretches it back and forth like a heartbeat. Each orbit needs the moon, heating it from within. That constant gravitational pull, combined with the tug of its sibling moons, creates tidal forces that generate unimaginable heat. It is as if the moon itself breathes fire. The result is a world in constant eruption. More than 400 active volcanoes puncture Io's surface, some shooting plumes of lava hundreds of kilometers high. These fountains rise into space before falling back as glowing rain. Rivers of molten sulfur carve new channels each day, freezing in bizarre colors as they cool. Yellow, white, orange, black. The air, such as it is thin and poisonous, made mostly of sulfur dioxide that sometimes freezes out and snows onto the plains. It is a moon both alive and desolate, brilliant and deadly. When the Voyager spacecraft flew past Io in 1979, scientists were astonished. They had expected a cold, cratered world, much like our moon. Instead, they saw a surface without impact scars, covered instead by smooth plains and volcanoes that glowed in infrared. One plume erupted even as the spacecraft watched, marking the first active volcano ever observed beyond Earth. Voyager's cameras revealed something the universe had never shown us before. A moon that behaves like a planet, still reshaping itself long after its birth. Later missions, Galileo in the 1990s, New Horizons in 2007, and Juno more recently, showed us that Io's surface is a shifting mosaic of chaos. Some volcanoes flare for years, while others vanish without warning. Entire mountains collapse into molten seas. The tallest of these volcanoes, named Loki Patera, is larger than any volcano on Earth and could engulf all of Iceland within its fiery rim. Every few months, it erupts in waves that can be seen from millions of kilometers away. To watch Io is to watch geology at its most dramatic, a stage where creation and destruction perform together in endless rhythm. But Io's drama is not isolated. Its volcanic heart fuels the entire Jovian system. The particles it throws into space form a vast torus of plasma that encircles Jupiter, feeding its powerful magnetic field. Lightning storms flash across the planet's poles, fueled by energy born from Io's fury. In a sense, this one small moon helps power the largest planet in the solar system. It is not merely a companion, but a source, a restless engine driving the dance of Jupiter's magnetosphere. This intense connection comes at a cost. Jupiter's magnetic field bombards Io with deadly radiation, hundreds of times stronger than what would kill a human in seconds. The moon's surface glows faintly under this invisible assault, and its atmosphere constantly shifts and collapses. From orbit, it is a world of silence, but beneath that silence, unimaginable violence unfolds every second. The ground moves, the air trembles, and the horizon glows with plumes of molten gold. And yet, there is beauty here. To see Io illuminated by Jupiter's reflected light is to see art painted by chaos. Its surface colors come from sulfur in its many forms: yellow and orange at moderate heat, red and black where the lava cools, and brilliant white where sulfur dioxide frost condenses. From space, the moon resembles a marble forged in fire, a paradox of vivid life and total desolation. It is a reminder that beauty in the universe often comes from extremes, from the edge between survival and destruction. Scientists believe Io's volcanic activity tells a story about how worlds evolve. The heat it endures from tidal friction may resemble what early Earth experienced when it was still molten. Studying Io helps us understand how geological energy can shape landscapes, atmospheres, and perhaps even prepare planets for life. Though Io itself is far too hostile for life as we know it, its eruptions echo processes that once created continents and oceans on our world. In this way, Io is both alien and familiar, a vision of our past, replayed in eternal fire. Despite the chaos, Io moves with perfect precision in its orbit. It is locked in a resonance with Europa and Ganymede. For every orbit Ganymede completes, Europa circles Jupiter twice, and Io does so 4 times. This gravitational dance keeps their orbits stable, but also guarantees that Io's surface never rests. The same rhythm that brings harmony to the Jovian system is what ensures Io's torment continues. The universe, it seems, balances beauty and suffering with quiet precision. No human has ever seen Io's volcanoes except through the eyes of machines, but the imagination easily fills the gaps. Picture standing there, if one could. The horizon would glow crimson and gold. Ash would fall like snow, yet so fine it would float in slow motion. The sky would not be black, but painted with Jupiter's immense form hanging overhead, its stripes swirling like a living god. The ground beneath would tremble softly, the pulse of tides from a planet hundreds of times larger than Earth. It would feel like standing on the edge of creation itself. From a spiritual perspective, Io is the universe's furnace, a symbol of transformation. Where Luna speaks of reflection and constancy, Io represents passion and change. It is the forge where matter becomes form, and form returns to chaos. In myths, fire is both destroyer and creator. Here, that truth is made real. Every eruption on Io is a small act of renewal, erasing the old and making way for the new. If Luna whispers of stillness, Io roars of becoming. Io's name comes from mythology, from a mortal woman loved by Zeus and transformed into a cow to hide her from the jealous goddess Hera. Chased across the earth by a stinging gadfly, Io wandered endlessly, restless, tormented, but enduring. It is a fitting name for this moon, forever in motion, forever changed by the forces that rule it. Just as the mythic Io wandered between gods, the moon Io wanders between tides of gravity and heat, caught in a cycle of pain and renewal that mirrors her namesake's fate. In studying Io, we glimpse the raw power that shapes planets. Its heat is not from sunlight, but from motion, the constant flexing of rock under gravity's pull. This process, called tidal heating, may also warm the hidden oceans of other moons like Europa and Enceladus. Thus, even a world of fire may help explain how life could exist in worlds of ice. In that connection lies one of science's most poetic truths, that every moon, no matter how different, contributes to the story of life's possibility. As space probes pass Io again and again, they capture images of plumes rising like delicate threads against Jupiter's glow. These images are more than data. They are windows into a dynamic world, a place where geology happens in real time. If you could listen closely enough, you might hear the hiss of sulfur vapor, the low thunder of molten rock meeting frost, the faint hum of Jupiter's magnetism coursing through the airless void. It is a symphony of forces too vast for human senses, yet its rhythm is the same that beats within stars and planets everywhere. And so, Io teaches us a strange serenity. In its violence, it is constant. In its turmoil, it is balanced. While we see destruction, the universe sees equilibrium, a system maintaining itself through motion and release. Perhaps this, too, is a lesson for us. That change, even the fiery kind, is part of the harmony of existence. To watch Io is to be reminded that chaos and beauty are not opposites, but companions, orbiting one another like moon and planet. As we drift away from Io, we leave behind the glow of its fires and the soundless roar of its eruptions. Ahead lies another kind of mystery, quieter, colder, but no less profound. Where Io burns with molten rock, Europa conceals an ocean of liquid water beneath its ice. One world is heat incarnate, the other, silence and potential. And between them flows the invisible energy that binds them to Jupiter, that binds all things to motion and balance. In our next chapter, we will descend into that frozen realm where darkness hides the promise of life, and the universe whispers through water instead of flame. Far beyond the burning world of Io drifts a moon, wrapped in silence. Europa, another of Jupiter's great companions, circles through the blackness like a frozen pearl. Its surface gleams with reflected sunlight, an almost perfect mirror of ice and stillness. Yet beneath that frozen crust, something extraordinary may stir, a hidden ocean, vast and ancient, where warmth and life might quietly endure in the dark. Europa was discovered like Io by Galileo in 1610. Through his small telescope, it was a faint star beside Jupiter's brilliance, moving in perfect rhythm with three others. To him, it was proof of celestial order, but not yet of wonder. Only centuries later did we learn that this small, icy world holds more water than all of Earth's oceans combined. That realization changed how we look at the universe. Where once we sought life only on Earth-like planets, Europa whispered that it might exist in the unlikeliest of places, beneath miles of frozen silence. Europa's surface is breathtaking in its simplicity. Unlike most moons, it has few craters. Instead, it is etched with a network of dark lines, fractures that crisscross its globe, like the veins of a living creature. Some of these lines are hundreds of kilometers long, carved by tides that flex the ice as Jupiter's gravity pulls at it. These ridges rise and fall, twist and break, creating a pattern as delicate and complex as a fingerprint. From orbit, it looks as though someone has drawn upon pure white marble with the ink of the cosmos. The surface ice is believed to be 10 to 20 kilometers thick, floating atop a vast ocean that could be 100 kilometers deep. Beneath that, Europa's rocky mantle may rest upon a metallic core, heated by the same gravitational forces that torment Io. As the moon is pulled and stretched in its orbit, its interior warms just enough to keep the water liquid. In this balance between cold and heat, stillness and motion, Europa may shelter one of the most promising habitats beyond Earth. Voyager's passing glimpse of Europa in 1979 revealed the first clues to this mystery. The images showed a world of ice without mountains, without shadows, with colors so faint they seemed unreal. There were few craters, evidence that the surface is constantly renewed. That smoothness suggested activity, as if something beneath the ice occasionally broke through, refreezing in patterns of grace and geometry. Later, the Galileo spacecraft confirmed these suspicions. It measured magnetic fields that hinted at a conductive layer, salt water, flowing beneath the crust. The implication was profound. Where there is liquid water, there may be life. Scientists imagine Europa's hidden ocean as a vast global sea, trapped beneath an unbroken ceiling of ice. In that eternal darkness, hydrothermal vents may rise from the ocean floor, releasing minerals and heat into the water. On Earth, such vents teem with life, creatures that draw energy not from sunlight, but from chemistry, thriving in blackness. If Europa shares this pattern, its ocean may be home to something living, something moving, something aware in the dark. Not grand civilizations, but perhaps simple organisms, bacteria, algae, or forms of life we cannot yet imagine, shaped by an alien sea. There is something profoundly human about this idea. The thought that life might persist beneath the ice, that warmth and motion can survive in hidden places, echoes our own experience. Europa becomes a metaphor for the resilience of life itself. Quiet, patient, waiting. In her silence, she reminds us that even when everything appears frozen, something may still move beneath the surface. The cosmos is full of deserts, but Europa may be an oasis buried under snow. To peer upon Europa is to see beauty forged in minimalism. The sunlight that touches her is faint, 25 times weaker than what brightens our skies, yet it glints upon the ice in silver tones. The cracks and ridges glow faintly blue, where salts and minerals from the ocean below have seeped upward and frozen. Each line is a record of movement, a memory of unseen tides rising and falling beneath the crust. The entire moon seems to breathe, slowly and silently, as if the ice itself were alive. The more we learn about Europa, the more it invites humility. It reminds us that we are surrounded by possibilities we barely understand. Life, as it turns out, does not require sunlight or soil. It requires balance between heat and cold, energy and stillness. It thrives wherever the universe allows motion, chemistry, and time. Europa may be one of those rare places where the right conditions have aligned, hidden just beyond the reach of our senses. The search to uncover that mystery has become one of humanity's quiet obsessions. NASA's upcoming Europa Clipper mission will orbit Jupiter and fly repeatedly past the Moon, using radar and spectrometers to peer through the ice. The European Space Agency's JUICE mission, short for Jupiter Icy Moons Explorer, will do the same, searching for heat signatures and chemical traces of organic material. These machines, built by hands on Earth, will carry our curiosity across 500 million miles of space to listen for whispers beneath the ice. They are emissaries of wonder, guided by a question that is as ancient as the stars. Are we alone? Europa offers no easy answers. If life exists there, it has endured for billions of years, without light, without warmth from the sun, without awareness of the cosmos above. That kind of life would be deeply alien, yet also deeply familiar. It would prove that life does not need to dominate or change its environment. It only needs to persist. To imagine such beings, drifting slowly through a black ocean, glowing faintly in the warmth of a vent, is to glimpse another form of peace. A kind of existence defined not by conquest, but by harmony. In many ways, Europa embodies the essence of silence. While Io screams with volcanoes, Europa whispers. Her world is one of patience, of rhythm, of tides beneath the still. The ice above her ocean is both barrier and protection, keeping the fragile warmth safe from the emptiness of space. The universe is loud with destruction, but here, in this quiet world, creation continues unseen. Perhaps it is fitting that the search for life should lead us to a place so tranquil, so hidden, so patient. To imagine Europa's ocean is to step into a dream of weightlessness. Picture floating beneath a ceiling of ice that stretches for miles, faint light filtering down from cracks above. The water is thick with minerals, shimmering like liquid glass. In the distance, vents rise like towers, exhaling heat into the cold. The currents move slowly, carrying life from one vent to another. In that eternal night, there is no fear, no haste, only continuity. Every droplet carries memory, every ripple a story billions of years old. When the first spacecraft eventually lands there, it may carry drills and sensors, seeking proof of life. But even if no organisms are found, Europa will still have given us something profound, a vision of possibility. She shows that life does not have to exist everywhere for the universe to be alive with meaning. The potential itself, the idea that it could, fills us with a sense of belonging. It tells us that creation is generous, and that even in isolation, there is connection. Europa also reminds us of fragility. Her surface, though solid ice, is thinner and more delicate than continents. A single impact or shift can reshape her entire appearance. In that fragility, she reflects something of Earth itself. Our oceans, too, are finite and precious, held in balance by forces beyond our control. When we study Europa, we are not just looking outward. We are seeing another version of home, one that teaches us gratitude for our own blue world. Through the lens of science, Europa is a promise. Through the lens of reflection, she is a poem, a frozen heart that beats beneath layers of time. The universe, it seems, loves contrast. Fire beside ice, silence beside sound, emptiness beside possibility. Europa exists between those opposites, in the thin space where miracles might happen. She is a reminder that not all life needs light, and not all hope needs proof. Sometimes, the mystery is the gift itself. And so, Europa turns quietly, in Jupiter's immense shadow. Her orbit carries her through radiation, through cold, through darkness. And yet, she endures. Beneath her crust, the ocean moves, slowly, eternally, stirred by the pull of distant gravity. Perhaps one day, we will pierce that ice and listen to the sound of water echoing through the void. Until then, Europa remains what she has always been, a world of secrets, a song of patience, a whisper of what life might be when no one is watching. In the vast court of Jupiter, one moon towers above all the rest, a colossal world so large it could almost be a planet in its own right. This is Ganymede, the giant among moons. Larger than Mercury, wrapped in ice and rock, it drifts through the shadow of Jupiter like a quiet sovereign, immense and serene. Where ice blazes with fire, and Europa hides her secrets beneath the ice, Ganymede stands as balance, a world of calm power, shaped by gravity and time into something both alien and strangely familiar. Ganymede was discovered in 1610 by Galileo, alongside Io, Europa, and Callisto. To his astonishment, this distant point of light was not just another star, but a body moving with order and grace around Jupiter. What Galileo could not have known is that Ganymede is the largest moon in the solar system, spanning more than 5,000 kilometers across. If it orbited the Sun instead of Jupiter, it would easily be called a planet. Yet despite its size, Ganymede remains a moon, a reminder that even giants can dwell in the shadows of greater forces. From space, Ganymede's surface appears both ancient and youthful. Half of it is covered with dark, cratered regions, remnants of a violent early history. The other half shines with grooved plains of lighter ice, etched with long, parallel ridges that stretch for thousands of kilometers. These grooves mark the scars of tectonic forces that reshaped the crust long ago, as the interior expanded and cracked. It is a world frozen in mid-transformation, holding both the memory of the past and the traces of renewal. In its silence lies the story of billions of years of slow, patient change. Unlike most moons, Ganymede possesses something extraordinary, a magnetic field of its own. When the Galileo spacecraft passed near it in the 1990s, its instruments detected this magnetic signature, a phenomenon previously seen only on planets. This means Ganymede's core must be partly molten, churning with metallic iron or nickel, generating a magnetic dynamo deep within. The moon's field interacts with Jupiter's enormous magnetosphere, creating shimmering auroras at its poles, curtains of light that ripple above the icy surface, unseen by human eyes, but as real and beautiful as those on Earth. That magnetic field tells us that Ganymede is still alive inside, though its heartbeat is slow. Beneath its icy crust lies not just one ocean, but perhaps several layers of water, sandwiched between rock and ice. Some models suggest there could be more than 100 kilometers of liquid ocean hidden below the surface, warmed by the faint heat of the core and the constant pull of Jupiter's tides. Each layer may have its own chemistry, its own temperature, its own potential for life. Ganymede, then, is not just a frozen sphere. It is a world of depths and mysteries stacked within one another, like pages of an ancient book. Imagine standing upon its surface. The sky would be dim and gray, lit not by the sun, but by the reflected light of Jupiter looming above. So vast it fills the horizon. The ground beneath your feet would be hard and silent, composed of rock and ice fused together over eons. Mountains of frozen water would rise and glimmer in the weak sunlight. In the distance, faint auroras might flicker, painting the horizon with ghostly colors. It would feel both alien and strangely peaceful, a place where time has slowed to the rhythm of cosmic patience. The story of Ganymede is a story of resilience. While Io burns and Europa bends under Jupiter's pull, Ganymede endures. It moves in perfect resonance with its siblings, 3 moons locked together in an elegant gravitational dance. Each time Ganymede orbits Jupiter once, Europa completes 2 orbits, and Io completes 4. This synchronization is not coincidence, but harmony, maintained for billions of years by the invisible music of gravity. Together, they form a natural symphony, a slow, repeating rhythm that shapes their orbits, tides, and inner heat. In this way, Ganymede is both participant and conductor in one of the universe's quietest masterpieces. Despite its cold and distant exterior, Ganymede may be one of the most Earth-like places in the outer solar system. It has a layered structure: core, mantle, crust, and atmosphere. It even has weather of a sort, though thin and ephemeral. Its tenuous shell of oxygen drifts just above the surface, too faint for lungs, but enough to hint at chemistry familiar to life. Though no living thing could breathe there, the idea that oxygen exists naturally on another world reminds us how often the universe repeats its patterns. Even in distant places, the ingredients for life appear again and again, as if nature loves to echo herself. When Voyager first flew past Ganymede in 1979, its cameras captured a world that defied expectation. The grooves and ridges were unlike anything seen before, neither purely geological nor entirely icy. Later, the Galileo orbiter revealed their complexity: bands of stretched and broken ice, marking where the crust had fractured and refrozen. These grooves may be relics of tectonic motion, the slow shifting of plates in a frozen medium. In Ganymede's distant past, tides and heat combined to create internal movement, reshaping the world in patterns that resemble continental drift. It was a frozen echo of Earth's own restless geology. Such parallels are haunting. On Earth, tectonics builds mountains and oceans, driving the cycle of renewal that sustains life. On Ganymede, similar processes once occurred in silence, unobserved, unremembered. If there was ever a time when the moon's ice shifted and flowed like glaciers, carving valleys and ridges, it may still continue deep below, slow as thought, unseen by the universe, except through the instruments of passing spacecraft. Ganymede moves not with speed, but with endurance, the kind that defines worlds meant to last. Beneath all this lies the ocean. The Galileo data suggested saltwater layers buried deep beneath the ice, possibly in contact with the rocky mantle below. If that is true, hydrothermal activity could feed those oceans with minerals and energy, just as it does on Europa. And though light never reaches those depths, warmth might. In that gentle warmth, where liquid meets rock, the chemistry of life could quietly unfold. The possibilities multiply like ripples in still water, bacteria drifting in dark currents, unseen ecosystems feeding on minerals, alien tides shifting in silence for billions of years. In its enormity, Ganymede teaches us humility. It is a reminder that not all greatness is loud or visible. Its power lies not in spectacle, but in balance, in the harmony between rock, ice, water, and magnetism. It endures without eruption, without chaos, without drawing attention. In this way, it resembles the quiet endurance of planets, the slow turning of galaxies, the patience of nature itself. Sometimes, what is most stable holds the most stories. The magnetic field that surrounds Ganymede may be weak by planetary standards, but it is strong enough to carve its own bubble within Jupiter's magnetosphere, a miniature magnetosphere within a larger one. Inside that invisible shield, charged particles spiral and dance. If you could see them, they would shimmer faintly around the moon, like dust caught in sunlight. When those particles collide with the atmosphere near the poles, they create auroras, thin, shifting curtains of blue light that pulse to the rhythm of Jupiter's magnetism. In Ganymede's eternal night, those auroras might be the only movement visible from the surface, a cosmic heartbeat flickering in slow, graceful intervals. Future missions aim to study this magnificent world in detail. The European Space Agency's JUICE mission, Jupiter Icy Moons Explorer, will make Ganymede its home, orbiting the moon to map its gravity, magnetic field, and internal structure. By then, we may finally know how thick its ocean is, how deep its crust runs, and whether its core still spins with molten life. Perhaps we will find more than data. Perhaps we will find reflection. For in Ganymede, we see a version of stability that contrasts beautifully with the chaos of Io and the fragility of Europa. Each moon teaches something different. Ganymede's lesson is strength and stillness. If you imagine Ganymede's world closely enough, you may sense what it would be like to stand within its calm. The silence would be immense, deeper than any on Earth. No wind, no sound of waves, only the faint hum of Jupiter's magnetism, the pulse of far-off auroras, the creak of ice under its own weight. The horizon would curve gently away, glowing faintly where the sunlight strikes. Above, Jupiter would dominate the sky, a vast, striped lantern that rises and sets like a living sun. Around it, the other moons would appear as tiny points of light, each one turning through its orbit in quiet synchronization. It would be a vision of balance, an entire system moving together, slow and eternal. And perhaps, deep beneath the ice, something stirs, currents, minerals, maybe even life. Not life as we know it, but something adapted to the stillness, the cold, the patience. On Ganymede, existence would not be measured in days or seasons, but in cycles of orbit and tide, in the slow exchange of energy across time. Whether inhabited or not, the ocean below remains a symbol of potential, of what endures unseen. It is the universe's way of reminding us that silence does not mean emptiness. Ganymede's enormity and calm presence give it an almost planetary dignity. It is both moon and world, both companion and sovereign. While it revolves around Jupiter, it holds its own magnetic heart, its own oceans, its own history. In every way that matters, it stands alone, a complete world bound only by gravity to a greater one. The cosmos is full of hierarchies, stars with planets, planets with moons, but Ganymede shows that within those relationships, individuality persists. Even in orbit, a moon can have identity, purpose, and grandeur. As we continue to observe it, Ganymede invites reflection on what it means to be vast and quiet. In a universe filled with noise and fire, here is a world content to turn slowly, to hold its secrets with grace. Its icy ridges glimmer like lines in an ancient script, and we, the readers, are only beginning to understand the language. Perhaps its meaning is simple: endurance. To last through time without losing oneself, to remain steady in motion, to hold oceans beneath a frozen face. These are the marks of cosmic strength. And so, Ganymede continues its endless path around Jupiter, patient and immense. While storms rage across its parent planet and volcanic plumes burst from its siblings, Ganymede watches, unshaken. It embodies the quiet resilience of the universe, the kind that survives not by force, but by balance. In the great symphony of moons, it is the bass note, deep and steady, anchoring the melody of creation. In its presence, one can almost feel the weight of eternity, soft and comforting, like the hum of a planet breathing in its sleep. In the deep outskirts of Jupiter's realm drifts a moon older than memory itself. Callisto, the outermost of the great Galilean moons, is the ancient one, the archivist of the solar system. Where Io burns and Europa hides oceans, Callisto simply endures. She is a world of silence and scars, her surface unchanged for billions of years, preserving the story of everything that came before. Callisto is almost as large as Mercury, yet unlike her siblings, she bears no sign of inner restlessness. She has no volcanoes, no tectonic grooves, no magnetic field. She is quiet, utterly still. Her surface is the oldest known in the solar system, a frozen relic untouched since the age of heavy bombardment. Every crater, every scar, every impact remains exactly where it fell. To look at Callisto is to gaze directly into time itself, to see the record of the early solar system written in stone and ice. When Galileo first saw her through his telescope in 1610, he could not know the story she carried. To him, she was simply another light circling Jupiter, smaller and slower than the rest. But modern spacecraft, Voyager, Galileo, and now Juno, have revealed a surface of astonishing detail. Craters layered upon craters, ancient basins surrounded by rings of uplifted ice. The largest of these, Valhalla, spans nearly 4,000 kilometers, its concentric rings stretching across a continent-sized area. It is the scar of a cosmic collision that would have shattered any lesser world. Yet Callisto remained intact, absorbing the impact with quiet resilience. Beneath that battered exterior lies a story of complexity, hidden beneath simplicity. Though long thought to be inert, Callisto may harbor an ocean deep below its icy crust, perhaps 100 kilometers beneath the surface. The Galileo spacecraft detected magnetic disturbances, suggesting a conductive layer, likely saltwater, within. If true, even this ancient world of scars may cradle a secret sea. Unlike Europa's restless ocean, Callisto's would be cold, dark, and still, perhaps trapped for billions of years in unbroken calm. But even that stillness carries beauty, a reminder that motion is not the only form of life. Sometimes endurance itself is its own kind of energy. Callisto's face tells a different kind of story from her siblings, where Io's surface is constantly erased by lava, and Europa's ice renews itself from within. Callisto's surface remembers everything. It is a map of time without revision. Each crater records an era, each fracture a moment of violence now long past. In her silence, she teaches continuity. the quiet persistence of what endures after chaos has burned itself away. The universe has many ways of creating beauty. Callisto's is through patience. The light that reaches Callisto is faint, sunlight weakened by Jupiter's distance from the sun. Yet she shines softly, reflecting enough light to glimmer like an old coin in the dark. From her surface, Jupiter would appear smaller than from Io or Europa, but still enormous, a muted sphere hanging low in the eternal night, streaked with amber and white. The gas giant's magnetosphere washes faint radiation over Callisto's plains, but compared to her inner sisters, this outer moon is a place of relative peace. Radiation here is low enough that humans could one day walk on her surface safely. In the cold stillness of her night, she may yet host humanity's first base in the Jovian system, a place of rest among giants. To imagine standing there is to imagine stillness made physical. The horizon would be dark gray and blue-white, dotted with craters stretching into the distance. The airless silence would be total, broken only by the faint vibration of your own heartbeat in your helmet. Jupiter would rise and set slowly, painting the ice in gold and shadow. Time would seem to stop, as if the moon itself had forgotten motion. You would be standing on 4 billion years of memory, each footprint pressed upon a surface older than life itself. Scientists study Callisto not only for what she can tell us about the past, but for what she might offer the future. Because of her low radiation and relative distance from Jupiter's magnetic field, she is considered the safest of Jupiter's major moons for human exploration. Her stable surface and abundance of water ice could one day provide resources for long-term missions. Imagine a research outpost carved into her ancient rock, humans gazing up at Jupiter from a frozen plain, recording data while the auroras shimmer faintly in the distance. Callisto, once a symbol of age and stillness, might become a stepping stone for exploration, a quiet haven in the outer dark. The moon's name comes from myth, from a nymph of Artemis transformed into a bear by jealousy and later lifted into the heavens as a constellation. It is a fitting name for a world that has endured transformation and exile. Callisto was cast outward from Jupiter's inner system, and her orbit remains slightly apart, as if by choice. While the other Galilean moons are bound in gravitational resonance, Callisto drifts freely, untouched by their rhythmic pull. She moves at her own pace, solitary and unbound, a wanderer keeping her distance from the dance of the others. In that solitude lies a quiet dignity. Her isolation may have preserved her from the forces that tore and reshaped her siblings. The lack of tidal heating means her interior has cooled and settled, preserving ancient structures deep within. Callisto is the control sample of the solar system, a world that has remained mostly unchanged since the beginning. Studying her is like reading the oldest pages of a cosmic diary, written before planets found their balance, before moons found their rhythm. She reminds us that even in a universe defined by motion, there is value in stillness. Some worlds exist not to change, but to remember. When the Galileo spacecraft sent back its final images, they showed a landscape that was neither hostile nor inviting, but peaceful. The craters glowed in soft blues and browns, their edges smoothed by time. Ice mingled with dust, creating hues of subtle beauty. There was no violence, no storms, no signs of geological activity, only the quiet dignity of endurance. The same surface that bore the scars of ancient impacts now rests untouched, illuminated only by the dim sun and the glow of distant Jupiter. It is a world that neither demands nor resists attention. It simply is. In a way, Callisto is the elder of the Jovian family, watching from the outskirts as the others continue their restless lives. She embodies the final stage of planetary evolution, the moment when heat fades, activity slows, and peace returns. To some, this may sound like decay, but to others, it is wisdom. The universe, too, ages. Stars burn bright and then cool into quiet embers. Galaxies spin for eons before drifting into equilibrium. Callisto mirrors that cosmic pattern, a reminder that there is beauty in the soft ending of motion. She may not possess oceans like Europa, or a magnetic field like Ganymede, but she carries something rarer, the unbroken truth of history. Every crater, every fracture, every grain of dust is evidence of events that shape the solar system. In her silence, she keeps the memory of creation intact. Perhaps that is her role, to serve as a witness, a guardian of time's earliest stories. To gaze upon her is to glimpse eternity's texture, the rough-pitted surface of survival. The future may yet awaken her in new ways. If humans one day settle her plains, they will bring warmth, light, and voices to a world that has known only silence. Their presence would not erase her stillness, but add a new chapter to it, the sound of humanity joining the story of the moons. Under her vast, star-filled sky, we might remember that even the most ancient worlds can find new purpose. Callisto, the Ancient One, might one day cradle the dreams of travelers seeking peace among the stars. And so she turns, slow and steadfast, her scars glinting like silver in the dim sunlight. She asks nothing, gives nothing, but offers everything: knowledge, perspective, and quiet. While younger worlds rush and change, Callisto reminds us that endurance has its own form of grace. The universe does not forget those who keep its memories. Among all of Jupiter's children, she remains the most patient, the timeless witness of what was, what is, and what may come. Far from the warmth of the sun, where light turns thin and golden, Saturn's largest moon circles its parent, like a dim lantern in the haze. This is Titan, the only moon in the solar system with a thick atmosphere, and the only one known to have liquid lakes and seas upon its surface. Yet, these are not seas of water. They are seas of methane and ethane, cold and alien, shimmering beneath an orange sky. Titan is the universe dreaming in slow motion, a world where chemistry, patience, and imagination intertwine. Titan is vast, larger even than the planet Mercury. If it orbited the sun, it would count as a world in its own right. Its atmosphere is dense, about 1.5 times thicker than Earth's, composed mostly of nitrogen, laced with methane and complex organic molecules. From orbit, Titan appears wrapped in orange fog, hiding its surface completely from view. For centuries, it was a mystery, its secrets concealed beneath a blanket of haze so thick that sunlight never reaches the ground directly. When the Voyager spacecraft flew past Saturn in 1980, its cameras could see little but the glow of this mist. Titan remained an enigma until the arrival of the Cassini-Huygens mission in the early 2000s. Cassini orbited Saturn for more than a decade, and the small Huygens probe detached to descend through Titan's atmosphere in 2005. As it fell for 2.5 hours, instruments recorded wind, temperature, and pressure, revealing the first true glimpse of a world both familiar and strange. When Huygens landed, it found a landscape sculpted by rivers, channels, and plains, shapes that looked carved by rainfall, though the rain was not water, but liquid methane, falling softly through the haze. To stand on Titan would be to stand inside a perpetual sunset. The sky would glow deep orange, the light dim and diffuse, as though filtered through amber glass. The air would be cold, 180 degrees below 0 Celsius, and every breath would freeze without a protective suit. Yet the wind would be gentle, the pressure comfortable. In that heavy air, a human could flap mechanical wings and fly with little effort. The ground beneath would crunch like packed snow, made of frozen water as hard as rock. In the distance, dark lakes would glisten under a dim reflection of the sun. Titan is a paradox, deadly and inviting at the same time. Cassini's radar pierced the clouds to reveal continents, dunes, mountains, and seas. Near the poles, vast bodies of liquid stretch for hundreds of kilometers. The largest, Kraken Mare, rivals Earth's Caspian Sea. Smaller lakes cluster like mirrors in a frozen wilderness. These seas are filled with liquid hydrocarbons, methane and ethane, that behave as water does on Earth. They evaporate, form clouds, and fall again as rain, creating a methane cycle that mirrors our own hydrological one. Where we have rivers of water, Titan has rivers of oil, carving valleys and deltas across its icy crust. It is a world where the familiar has been rewritten in a new language. Scientists believe Titan's thick atmosphere shields a complex chemistry taking place high above its surface. Sunlight breaks apart methane molecules, forming long chains of hydrocarbons that drift downward like golden snow. These particles accumulate into organic haze, raining onto the ground to create dunes of dark material, carbon-based compounds that might one day seed prebiotic chemistry. Some researchers think Titan may resemble the young Earth before life began, a laboratory of natural chemistry waiting for a spark. Others believe an ocean of liquid water, mixed with ammonia, may lie deep below the crust, warmed by Saturn's tides. If so, Titan would possess both the chemistry and the energy needed for life. Just not life as we know it. There is a profound stillness in Titan's world. Winds move slowly, dunes shift over centuries, and rain falls perhaps once every few years. Yet that slowness does not mean emptiness. It means patience. Every process on Titan unfolds at the pace of cold and time. A single drop of methane falling from the orange clouds might take an hour to reach the ground, landing softly upon a lake that will not ripple. Each molecule participates in a cycle that has persisted for eons. In that still rhythm, Titan whispers the lesson that life, and perhaps consciousness, need not rush to matter. The discovery of liquid on its surface changed our understanding of where life could exist. Before Titan, we imagined oceans only in warmth, but Titan's seas are proof that liquid stability can emerge even in the farthest cold. Life, if it appears there, would have to adapt to a chemistry utterly different from ours. Methane instead of water, acetylene instead of oxygen. It might use membranes of hydrocarbons instead of lipids, its biochemistry slow and deliberate, unfolding at the temperature of liquid gas. Though such life is hypothetical, its possibility expands the boundaries of imagination. The universe, Titan suggests, is far more inventive than we once believed. To gaze upon Titan through Cassini's eyes is to see alien beauty written in subtle shades. The radar images, though monochrome, reveal elegance in form, meandering channels, braided deltas, coastlines shaped by invisible tides. Light echoes softly from smooth surfaces, dimly reflecting Saturn's rings above. When Cassini made its final pass, scientists watched the moon's faint reflection vanish into the darkness, knowing they had glimpsed something singular, a moon behaving like a planet, alive with atmosphere, weather, and motion. Titan's slow revolution around Saturn takes 16 Earth days, each day lasting as long as a lunar month. During that time, sunlight creeps across the surface, filtered by haze until even noon feels like dusk. The cold preserves everything. A footprint could last 1,000 years before winds erase it. The dunes near the equator form from organic grains, each the size of sand yet made from soot. They rise in sinuous waves that stretch for hundreds of kilometers. The methane seas near the poles may freeze and thaw with the seasons, exhaling vapors that form new clouds. The entire world moves as if half asleep, dreaming, waiting, and remembering. Among all the moons, Titan feels most like a cousin to Earth. Both worlds share thick atmospheres, active weather, and liquid on their surfaces. Both have landscapes sculpted by rain and erosion. But where Earth breathes oxygen, Titan breathes methane. Where our oceans sparkle blue, Titans shimmer black. And yet, in those differences, we see connection. The same physical laws, the same gravity and chemistry, shaping two very different outcomes. Titan reminds us that nature repeats her melodies in infinite variations. The future of Titan may soon bring new explorers. NASA's upcoming Dragonfly mission, a drone-like rotorcraft, will fly through its skies in the 20s, sampling soil, sniffing the air, and landing on dunes of organic dust. It will follow the trail of prebiotic chemistry, searching for molecules that could have formed the building blocks of life. Its rotors will spin slowly in the dense air, drifting from site to site beneath the orange clouds. Each flight will be a small act of wonder, an echo of human curiosity, reaching farther than warmth, farther than comfort, to touch the edges of possibility. In mythology, Titan was one of the elder gods, beings of immense strength and endurance. The name fits this moon perfectly. It endures in cold so deep that air turns to fog, yet its chemistry dances with potential. It stands as a monument to persistence, a place that waits for time to finish its experiment. Whether life ever arises there or not, Titan shows us that creation does not need speed or sunlight. Sometimes it needs only quiet and patience, and an ocean of dreams made from methane and light. In the stillness of Titan's twilight, Saturn looms above like a guardian haloed by rings. The planet's reflection ripples faintly across the black seas. If you could stand on the shore of Kraken Mare, the air would hum softly, the distant rings shimmering in gold. Nothing would move. Even your breath would sound like thunder in the silence. It is a place both foreign and familiar, a mirror for humanity's own search for meaning amid vastness. Titan does not shout its secrets. It waits, content in the slow poetry of existence. And in that patience, perhaps, it holds the secret of creation itself. Far out in the Saturnian system, a small moon shines like a piece of polished ice. Only 500 kilometers across, Enceladus is tiny compared to Titan or Ganymede, yet within its frozen shell beats one of the most astonishing hearts in the solar system. Beneath its glittering crust lies an ocean, a vast sea of liquid water warmed from below and venting into space through towering plumes of ice. Enceladus is the cryovolcanic jewel, a world of frozen fire and hidden oceans, whispering softly into the void. Enceladus was discovered in 1789 by the astronomer William Herschel, but for nearly 2 centuries, it remained just another faint speck among Saturn's many moons. Then, in 2005, everything changed. As the Cassini spacecraft orbited Saturn, it noticed something strange near Enceladus's south pole. Jets of vapor and ice erupting hundreds of kilometers into space. These geysers, lit by sunlight, formed a shimmering plume that glittered like a halo. Cassini flew through the plume and detected water vapor, salts, and organic molecules, the unmistakable ingredients of potential life. In that moment, a moon no larger than England became one of the most exciting worlds ever discovered. To see Enceladus from space is to glimpse perfection. Its surface is brilliant white, among the most reflective in the solar system. This albedo means it bounces back nearly all sunlight, keeping its surface temperature below -200 degrees Celsius. The landscape is a frozen masterpiece. Fractured plains, smooth basins, and ridged faults crisscrossing the crust like veins of crystal. Unlike most small moons, Enceladus looks alive. Its surface is geologically young, constantly renewed by ice rising from within. While craters cover much of the solar system, here they are scarce, erased by the moon's own internal activity. It is a world in motion, cloaked in frost. The South Pole is the key. There, a network of long, dark fissures stretches across the surface, lines of heat and energy called tiger stripes. These fractures, each more than 100 kilometers long, vent gas and particles from the ocean beneath. The plumes burst forth continuously, sometimes rising higher than the moon itself. They form icy arcs that feed Saturn's faint E-ring, replenishing it with fresh material. Cassini flew through those plumes again and again, tasting their contents with its instruments. What it found astonished scientists: complex organic molecules, salts, silica grains, and traces of ammonia, all signs of a warm, chemically active ocean below. That ocean may be global, stretching beneath the entire icy crust. Gravity measurements reveal that Enceladus is slightly flattened at the poles, consistent with a liquid layer, separating the ice from the rocky core. Deep within, tidal forces from Saturn's gravity flex and heat the interior, keeping the water from freezing. Hydrothermal vents may spew minerals into the ocean, just as they do on Earth's seafloor. There, around volcanic chimneys, microbes thrive in darkness, feeding on chemical energy. On Enceladus, a similar process could be occurring right now. Life powered not by sunlight, but by heat and minerals, drifting through a hidden sea. The idea that such a small moon could host an ocean was once unthinkable. Yet Enceladus demonstrates that size is not destiny. With only 1% the diameter of Earth, it still sustains one of the most promising habitats for life beyond our planet. In its delicate balance between ice, rock, and gravity, it has achieved something extraordinary: internal warmth without sunlight, a self-contained ecosystem powered by motion. It is as if the moon itself has found a way to keep its heart beating in the cold vacuum of space. Cassini's close flybys revealed even more. Thermal maps showed that the tiger stripes were far warmer than expected, dozens of degrees hotter than the surrounding ice. As the spacecraft passed through the plumes, it detected tiny grains of silica, proof of hot water interacting with rock at temperatures above 90 degrees Celsius. This is exactly the kind of environment on Earth where life thrives, deep under the oceans near hydrothermal vents. There, bacteria and archaea feed on chemicals like hydrogen and sulfur, forming the foundation of ecosystems independent of sunlight. Enceladus may host something similar, microbes drifting through dark water, feeding on minerals and releasing bubbles of methane that escape through the cracks above. To imagine standing on Enceladus is to imagine quiet power. The ground beneath would shine like glass, sculpted by ice and gravity. The horizon would curve sharply, and above it, Saturn would fill the sky, immense and golden, surrounded by its rings. The light would be pale, almost ghostly, reflecting from the planet's bands onto the ice below. At the South Pole, faint plumes would rise like frozen breath, drifting slowly upward, illuminated by Saturn's reflection. The sound would be nothing but silence, absolute and infinite. Yet within that silence, the moon would hum with hidden motion, its ocean moving beneath your feet, warm and alive. Scientists sometimes call Enceladus a cryovolcanic world, meaning volcanoes of ice instead of fire. Its eruptions release water and vapor rather than molten rock. But the process is similar. Pressure builds, fissures open, and material from deep inside escapes into space. This cryovolcanism recycles the surface, smoothing it over time. It also vents the interior secrets into the void, making Enceladus a place where we can literally sample a subsurface ocean without drilling a single hole. Each plume that bursts from the tiger stripes carries traces of the world below, chemical messages written in vapor. Cassini reads some of them, but many more remain unread. What makes Enceladus so captivating is not just its beauty or its geysers. It is its invitation. It invites us to wonder whether life might exist in forms entirely unfamiliar. Could cells thrive without sunlight, drawing energy from stone? Could evolution occur in the dark, in a sea where time flows differently, and every chemical reaction takes centuries? The answers may be drifting right now through those icy jets, frozen mid-flight, waiting to be caught by the next passing probe. In the coming decades, new missions are being designed to return to Enceladus. Some will orbit Saturn again. Others may fly through the plumes with more advanced instruments, or even attempt to land near the tiger stripes to study the jets directly. The dream is to detect unmistakable signs of life, amino acids, lipids, or complex organic chains that cannot form by chance. It would be the discovery of a lifetime, proof that life is not unique to Earth, that the universe is fertile in ways we are only beginning to understand. But even without that discovery, Enceladus has already changed us. It has reminded humanity that the conditions for life are not confined to warm, sunlit worlds. Life may hide in the coldest corners, beneath layers of ice and silence, waiting to be found. The little moon that once seemed insignificant now stands as one of the most promising homes for life beyond Earth. In the hierarchy of cosmic wonders, Enceladus has earned its place among the giants. And so it continues to orbit Saturn, feeding the faint E-ring with its shimmering breath, glowing like a pearl against the darkness. Each plume is a whisper of water into space, a message from a hidden ocean calling across the void. The sunlight glints off the ice crystals, scattering rainbows that no eye can see. Enceladus spins slowly, releasing its stories grain by grain. It is the poetry of persistence, a frozen heart that keeps beating quietly in the endless dark. If there is such a thing as cosmic grace, perhaps it looks like this: a tiny moon, gleaming in the shadow of a giant, giving more than it takes, shining not with heat, but with reflection. Enceladus, in its modesty, teaches that greatness does not depend on size or brightness. Sometimes it is found in purity, in balance, in the delicate dance of ice and fire. Beneath the frozen crust of this small world lies an ocean that may hold answers to some of our oldest questions about life, about creation, about the quiet endurance of the universe itself. In the farthest reaches of the solar system, where sunlight fades into starlight, Neptune circles in silence. Around it drifts a single large moon, Triton. It is a world of paradoxes, ancient yet active, frozen yet dynamic, distant yet strangely familiar. Among all the moons, Triton is unique. It does not belong where it is. It was captured, stolen from the depths of the Kuiper Belt, drawn into Neptune's embrace long ago. Since then, it has orbited backward against the planet's rotation, a quiet reminder that even in the heavens, exile can find a kind of peace. Triton's discovery came in 1846, just weeks after Neptune itself was found. The British astronomer William Lassell spotted it through his telescope, noting its faint movement against the background stars. For more than a century, Triton remained little more than a point of light, too distant, too cold, too mysterious to reveal its face. Then, in 1989, Voyager 2 swept past Neptune, sending back humanity's first and only close-up images. What it revealed was astonishing. Triton was not a dead world, but one alive with activity. Geysers, plains, and strange patterns sculpted by forces we barely understood. Triton is large, almost the size of our moon, and its surface gleams in shades of pink and white, a blend of nitrogen frost and methane ice. At temperatures near -235 degrees Celsius, it is among the coldest known places in the solar system. Yet even in that unimaginable cold, Triton moves, breathes, and reshapes itself. Voyager's cameras captured plumes of gas erupting from the surface, geysers of nitrogen shooting 8 kilometers into the sky, carried sideways by thin winds, before settling back to the ground as dark streaks. These cryovolcanoes, powered by sunlight filtering through the icy crust, reveal that Triton, like Enceladus, is far from still. Triton's orbit defies the usual order. It travels around Neptune in the opposite direction of the planet's rotation, what astronomers call a retrograde orbit. This means it did not form alongside Neptune, but was captured later, likely a former dwarf planet, similar to Pluto, pulled from its path and ensnared by Neptune's gravity. The capture would have been violent, causing immense tidal forces that tore at Triton's interior and reshaped both body systems. Smaller moons that once circled Neptune were likely thrown out or destroyed. What remains is a single great survivor, circling its captor with quiet grace, forever moving against the tide. This retrograde orbit is slowly decaying. Over millions of years, friction between Triton's motion and Neptune's gravity will draw it closer and closer, until one day it crosses the Roche limit, the point where tidal forces will rip it apart. When that happens, Triton may form a vast ring around Neptune, rivaling Saturn's in beauty, though that moment lies billions of years ahead. For now, Triton remains whole, turning slowly beneath the dim sunlight. A captured wanderer, writing its final chapter in tranquility. Beneath its frozen surface, scientists believe Triton may conceal an ocean, just as Europa and Enceladus do. Evidence comes from its smooth plains, its magnetic behavior, and its youthful terrain, which shows few impact craters. This suggests resurfacing, renewal powered by internal heat. Though the surface is made mostly of nitrogen and water ice, Voyager saw patterns resembling lava flows, but of frozen ammonia and methane instead of molten rock. Some scientists believe that radioactive decay within Triton's core provides enough warmth to keep a layer of water liquid deep below, perhaps laced with antifreeze chemicals. If so, Triton's hidden ocean may be the most distant sea in the solar system. To imagine standing on Triton is to imagine solitude perfected. The horizon would curve sharply, the sky black, but tinted faintly blue by nitrogen haze. The sun, though shining as it does everywhere, would appear no larger than a bright star, offering only a whisper of warmth. Neptune would dominate the sky, a deep azure disk swirling with storms and dark bands. From Triton's surface, you would see the planet hanging motionless, its rings faint and delicate, its atmosphere forever roiling in slow motion. The silence would be total, the temperature so low that air itself lies frozen to the ground. Every sound, every motion would seem to occur inside a dream. Voyager's close images showed a world of strange beauty. The terrain is marked by cantaloupe-like patterns, rounded ridges and depressions, formed by repeated cycles of freezing and thawing. Elsewhere, smooth plains stretch for hundreds of kilometers, interrupted by the remnants of ancient ridges and cryovolcanic domes. There are frozen lakes of nitrogen, streaked dunes of dark material, and even cliffs where sheets of ice have broken and drifted like glaciers. It is a world sculpted by chemistry and time, by frost and evaporation, by forces working so slowly that they blur the line between movement and stillness. Though only one spacecraft has ever visited Triton, its mysteries linger in the minds of scientists. Its retrograde orbit, its active surface, and its resemblance to Pluto suggest a shared origin in the Kuiper Belt, a region of icy bodies beyond Neptune that includes countless frozen remnants of the early solar system. If Triton was indeed once a dwarf planet, it may have had its own moon, its own atmosphere, its own quiet solitude before being captured. Now, bound to Neptune, it reflects the story of transformation, how even worlds can change homes, finding beauty in exile. Plans are being made for future missions to return to this distant moon. The proposed Trident mission, for example, would fly past Triton to study its surface, its plumes, and its potential ocean. With modern instruments, it could reveal whether those geysers still erupt, whether Triton's crust conceals organic chemistry, and whether life could exist there in some frozen form. Such missions take decades to plan and travel, but their purpose is simple: to listen more closely to what this quiet wanderer has been trying to tell us for eons. In mythology, Triton was the son of Poseidon, the messenger of the sea, blowing his conch shell to calm or rouse the waves. The moon named after him carries that same duality: frozen calm on the surface, hidden motion beneath. It is the voice of the outer ocean, speaking softly from the edge of the sun's reach. In its icy plumes and shifting plains, Triton reminds us that life's possibilities extend far beyond warmth and light. Even in the deepest cold, the universe continues to breathe. As Neptune turns slowly below, Triton glides against the flow, orbiting in defiance yet in harmony. It is the poet among moons, the exile who found serenity in distance. It circles forever backward, but never alone. Neptune's reflection fills its sky, and the sun's distant fire still glints on its frost. In that fragile light, the captured wanderer drifts on, dreaming of the time before capture, of the freedom it once knew, and of the silence it now keeps. Triton is proof that even in the coldest night, movement continues, beauty endures, and memory survives. Beyond Neptune's domain, past the dim frontier of sunlight, lies a small world locked forever with its companion. This is Charon, the great moon of Pluto, though the word moon hardly does it justice. Together, Pluto and Charon form a double world, two spheres bound by gravity's quiet pact, each circling a point of balance that lies in the empty space between them. They are partners in solitude, drifting side by side at the edge of the sun's reach, sharing one another's gaze through an endless cosmic night. Charon is half the size of Pluto, large enough that their relationship defies ordinary rules. Instead of one body dominating the other, both revolve around a mutual center of gravity that lies above Pluto's surface. Astronomers call this a binary system, a duet rather than a hierarchy. From Pluto, Charon never rises or sets. The same face always looks down, locked by tidal embrace, just as Pluto shows the same face in return. They are eternal dance partners, caught in perfect stillness, rotating once every 6 Earth days, spinning in a rhythm so steady it feels like sleep. Charon was discovered in 1978 by James Christie, who noticed a small bulge moving back and forth across photographs of Pluto. At first, it was thought to be an imperfection on the film, but the pattern repeated too precisely. That flicker turned out to be a world, Pluto's companion, a mirror in the darkness. When the New Horizons spacecraft flew past in 2015, it captured the first clear images, revealing a rugged, fascinating landscape, mountains of ice, deep canyons, and vast plains of frozen water and ammonia. Charon, once thought to be just a lump of rock and ice, became a place of subtle grandeur. Its surface tells a story of internal change. A colossal canyon system, far larger than the Grand Canyon, cuts across its hemisphere, signs of a crust that once cracked and expanded. Some regions are smooth, suggesting ancient cryovolcanic flows, where water once welled up and froze, resurfacing the terrain. Others are darkened by deposits from Pluto's escape in atmosphere, material that drifts across the gap and settles on Charon's North Pole, painting it in shades of red. Scientists call this region Mordor Macula, a poetic name for a frozen scar of cosmic exchange. Even in the outer darkness, worlds continue to interact, shaping one another with invisible breath. Charon's interior may once have held an ocean, long frozen by now, but the evidence of expansion and fracture hints at a warm past. As the moon cooled, its inner layers likely froze and expanded, splitting the crust apart. These wounds remain as canyons kilometers deep, testaments to the moon's ancient dynamism. Today, the surface temperature hovers around -200 degrees Celsius. No winds blow here, no rain falls, only the slow dance of shadow and light as Charon turns through its endless cycle. To stand on Charon's surface would be to feel true isolation. The horizon would stretch wide and gray, sculpted by ice cliffs and ridges. Above, Pluto would fill the sky, a dull orange orb hanging motionless, large enough to cast faint twilight across the landscape. Beyond that, the stars would blaze unshaken by atmosphere, sharp and unblinking. The sun would appear no brighter than a distant pin of light, so far away that its warmth could not be felt. The silence would be absolute, interrupted only by the imagined hum of one's own heartbeat inside a suit. In that stillness, one would understand what it means to stand at the threshold of the solar system, to be both part of it and beyond it. The bond between Pluto and Charon is one of equilibrium and companionship. Unlike other moons, which orbit as subordinates, Charon moves as an equal. Their shared balance point symbolizes a quiet truth about gravity and relationships alike. Sometimes harmony comes not from dominance, but from mutual respect. The two worlds have been bound this way for billions of years, their motion so stable that it feels eternal. When sunlight strikes their icy surfaces, it glows faintly blue and pink, as if the pair themselves were dreaming of gentler skies. In mythology, Charon was the ferryman of the dead, guiding souls across the river to the underworld. Fittingly, this moon stands as a guide between light and darkness, between the inner warmth of the planets and the cold expanse beyond. It marks a boundary, not an ending, a place where our solar system fades into the interstellar sea. From here, the sun is just another star, and beyond it lies infinity. Yet even here, in the coldest night, the laws of nature continue to weave their gentle patterns. Gravity still binds, light still travels, and motion still whispers that the story is not over. The New Horizons mission transformed our understanding of this distant pair. It revealed Pluto's mountains of nitrogen ice and Charon's fractured plains, showing that even at the edge of the sun's domain, worlds remain active and expressive. These were not dead remnants, but living sculptures, evolving slowly over eons. New Horizons captured them in their frozen waltz, a moment of cosmic intimacy suspended in time. It reminded us that exploration does not end with proximity. Sometimes, the greatest discoveries happen at the farthest distances, where curiosity meets silence. Beyond Pluto and Charon lies the Kuiper Belt, a realm of icy bodies that drift in slow orbits, relics of the solar system's birth. Some are large enough to be called dwarf planets. Others are fragments of frozen time. Together, they form a halo around our sun, a frontier where the known fades into the unknown. Charon, gazing outward from its eternal orbit, is our outpost at that frontier, a sentinel watching over the space between what is familiar and what lies beyond. It stands at the edge, calm and enduring, embodying the final quiet breath of the solar system before the long silence of interstellar space. Perhaps that is why Charon feels so symbolic, so human. It represents companionship in isolation, warmth in the coldest places, and the unbroken bond that holds two worlds together across eternity. In the vast distances that separate stars and planets, it is easy to forget that gravity itself is a form of connection, a promise that no object, no soul, truly drifts alone. Pluto and Charon, turning endlessly around their invisible center, embody that promise. Together, they remind us that even at the edge of everything, there is always something or someone to orbit. And so the story of the moons comes to rest here, where the sun's light grows faint, but never disappears. From Mercury's barren skies to Jupiter's storms, from Titan's orange haze to Enceladus's glittering plumes, and now to this distant pair, the solar system's moons have shown us every face of nature: fire and ice, chaos and calm, solitude and kinship. Charon and Pluto drift on together, two wanderers in an endless dark, bound not by distance, but by quiet affection, written in gravity itself. At the farthest edge of light, they turn forever, silent, steadfast, and beautifully awake.